through all these, but hopefully like the process of setting these up is starting to make sense. Perfectly inelastic means they stick together. I didn't get into the naming of different collisions, mostly because we didn't have time at the very end, but also because College Board doesn't really get into it either. And there's a reason for that. There are 4, in my opinion, types of collisions. Ones that start together and push apart, which everyone has called explosion collisions, even though it's like an anti-collision because you're already together and you're pushing apart. But they're called explosions, and momentum is conserved in those cases. Actually, momentum is conserved in all 4 of these cases, so it doesn't really matter. And then there's 3 other ones. There is one where they come together and then stick. There's one where they come together and then bounce apart and some energy, kinetic energy, is lost. And there's some where they come together, bounce apart, and kinetic energy is conserved. Unfortunately, outside of the explosion one, we have stick together, bounce apart, lose energy, bounce apart, conserve energy. But the words that are used are elastic and inelastic. 2 words that are meant to describe 3 different types of collisions. And so some books that you'll read will call things that where they stick together perfectly inelastic. Where they bounce apart and lose energy, they'll call that just regular inelastic, but they don't use regular. And then if they bounce apart and conserve kinetic energy, they'll call that elastic. But others will call collisions where they stick together just inelastic, bouncing apart, losing kinetic energy, elastic, and then bouncing apart and conserving kinetic energy, perfectly elastic or completely elastic or something like that. And so because different books kind of do different things, College Board has, for the most part, not used those words. Or when they do, it's really, really obvious what they're trying to get at. Their College Board does a pretty good job of trying to not have ambiguity in their answers. They want to know that, like, oh, they don't have to give credit for all these things, or they don't have to like not score some of the problems. Did I already send you that? Yeah, well, I don't know if 2 is going to be a last. 2 is going to be, yeah. So the reason where they're saying elastic, they're saying it has to conserve kinetic energy there. But we'll get to all of that later. But mainly what I wanted to do with these 4 problems is show you that they asked you about energy in half of these momentum problems. And I would like to say that's just them being difficult, but that's a really common practice in College Board and non-College Board momentum problems. Now, the reason why is that 1, you have just done the energy unit before momentum, and it's always good to pull in other things. But 2, College Board's trying to meet a quota. They need to hit certain benchmarks of what's being asked for and how it's being asked for. What does momentum have to deal with? Mass and velocity. What does kinetic energy have to deal with? Mass and velocity. And so with the same two pieces of information, you can get both momentum and kinetic energy. So why check off one box when you can check off multiple boxes? And so really what College Board is doing, and what you should be ready for on momentum problems. I mean, I know that it's August and we're talking about May of 26 already, but what you should also be ready for, I guess, in your classroom, but I don't know, I feel like classroom problems are a little bit lower. Whatchamacallit, they're not as like, not that they're not important, but that's the first word that comes to mind. There's going to be kinetic energy questions in the momentum unit. And it's not just because of the type of collision, it's also because they just want to check boxes. And so for this one here, what you find out pretty quickly, hopefully, is that 50, this is north, so I'll say that's positive. South, I'm going to say is negative. So 50 times 4 plus 40 times negative 5, and they stick together, so is equal to 50 plus 40 times v. But as you can probably see here, they're going to stick together and not move. So their final kinetic energy is going to be 0. But our initial kinetic energy is going to be 1/2 50 times 4 squared plus 1/2 40 times, I'll still keep it as negative 5, but it does get squared. And so I believe if you were to do this, that ends up being like 900 joules, I think. 50 times 16 plus 40 times 25 divided by 2, yeah, 900. So, and then in this case, it's a rear end collision. They're going the same direction. So 1200 times 20 plus 1000 times 15. They become locked. So that's going to be 1200 plus 1000 times v. I got v to be 17.7. 75, I think. So that's a lot. This is not something that you would see on a College Board exam just because they don't have the time for that. They try to keep the problems to be about 25 minutes long. This, I don't know if this would be like fair game. This seems more like a 15 to 20 minute AP Physics C problem just because it's how much more mathy it is. They're not asking you to like write a short paragraph telling me how you feel about this problem like they would in Physics 1. But this is pretty much a culmination of everything we've done in this course.